In this video, we're going to be doing some examples describing the left and right end behavior of a polynomial function. But before we do so, I just want to review a couple of things and bring up the importance of the leading coefficient when identifying end behavior for a polynomial. So in the last video, we looked at even degree and odd degree polynomials, and we saw in an even degree polynomial that your y values are increasing regardless if we're looking to the left or to the right of the function. And in an odd degree polynomial, that your y values are decreasing when you look to the left, but are increasing when you look to the right. So what happens when we have a leading coefficient that is negative? So I'll give a little example of that, right? So let's just say we had something like negative x to the fourth, plus whatever, 7, something along those lines. What happens here? Well, when we were graphing, we saw that when we take the opposite of a function, that this thing is going to get reflected over the x-axis. So this function is going to end up getting reflected over the x-axis, so it ends up opening downward. So as we look to the left, now our y values are decreasing. They're going to negative infinity. And as we look to the right, our y values are also decreasing. So you can see here that leading coefficient has a big effect on our end behavior, right? It completely changed. Our end behavior was increasing in both directions before, and now it's decreasing in both directions. So let's see what happens when we have negative leading coefficient for something that has an odd degree. And again, it would look something like this. So I'll just take the picture. Okay, the picture above doesn't exactly match the equation, but it's a rough estimate. But if we have a leading coefficient that is negative again, now you're going to have that thing reflected over the x-axis again. So it's going to look something like this. And now as we look to the left, then our y values now are increasing. You can see that right here. And as we look to the right, our y values are decreasing. So again, it has completely swapped the end behavior by reflecting that over the x-axis. So let's look at a couple of examples here. So f of x is equal to negative x cubed plus 4x. So first we want to identify the degree. Okay, the degree is 3. Okay, that is odd. Okay, so that's what we need to be thinking about. That is odd, and it will look something like that. Okay, at least, again, the graph may not be that accurate, but the end behavior will be the same as what I've drawn there. But we have a leading coefficient that is negative. So that means that this thing gets reflected over the x-axis, so it should look something like this now. Okay, it was going down on the left, now it's going up on the left. It was going up on the right, now it's going down on the right. So our answer should be that when x is going to negative infinity, that means it's going to the left, our y values, f of x, are increasing, so they're going to positive infinity. And as we look to the right, as x is going to positive infinity, our y values, f of x, are going down towards negative infinity. Okay, so that's our answer for part A. Part B. So we have our highest exponent is 4, so that means our degree is 4, which is even. So looks something like that. Okay, again, graph may not match that equation, but the end behavior does. our leading coefficient is positive, which means we don't have to change our graph at all. So now I can describe my end behavior. So as x is going to negative infinity, this is us looking to the left. F of, I should write it in the same line, f of x is going to positive infinity, so it's going up. As x is going to positive infinity, now we're looking to the right. F of x is going to positive infinity again, okay, going up in both cases. And one more example. So our highest exponent is 5, so our degree is 5, which is odd. So it looks something like this. Our leading coefficient is positive, so like this is actually something that I need to specify. Our leading coefficient is, we're looking at the sign of the term with our greatest exponent. Okay, so that's not something that I specified up above. So I should. Let me just take the time to do that. Right, so our leading coefficient, it may not always be in front, but it's going to be in front of the term with the greatest exponent. So it just so happens that in each one of these three cases, it is the first term, but it doesn't necessarily have to be the first term. Right, so let's just say, say this equation was given to us as, it's kind of a mess, can't even see it, that's a minus sign. So say the equation was given as negative x plus x to the fifth. Our leading coefficient is still positive because that x to the fifth term is positive. So because it's positive, our graph doesn't change. So we could use that quick sketch that I have there to describe the end behavior. So as we look to the left, our y values are going down. And as we look to the right, our y values, or our f of x values, are going up. And that is how you describe the end behavior of a polynomial.